Today we got a video on arithmetic and geometric series, which continues our unit on sequences and series. Today we're gonna work on part one of two. So this will be part one of the lesson. Part two we'll do on the next day. So to start, I want to consider the series of natural numbers from 1 to 100. So first off, what are natural numbers? Natural numbers are counting numbers. They're positive integers. So if we're going from 1 to 100, the series would look like 1 plus 2 plus 3 plus 4 plus ... Plus, I'm going to show a little bit at the end of this series what it will look like. So we would have plus 97, plus 98, plus 99, plus 100. Now, if I wanted to find the sum of this series, it would take a while to calculate 1 plus 2 is 3, plus 3 is 6, plus 4, 10, plus 5, 15. I could go on and on, right? It could take some time. Now, a famous mathematician noticed, okay, first thing you notice, this is arithmetic. Okay, this is an arithmetic sequence, or an arithmetic series, because there's pluses in between. So, is there a pattern that I could recognize here? And here's what he did. Pretty clever. He took 1 and he paired it with 100. Okay? So what's the sum of that pair? $101. Okay. So let's see what he did next. He took 2 and he said, okay, what's that sum? Well, that's also 101. Okay, interesting. He said, if I take 3 and 98, I get 101 there as well. And you can see without writing, 4 plus 97 is also 101. So he's like, I have this repeated sum throughout this whole series. So he wondered, okay, well, how many of those pairs are there? Well, there's 100 terms, and if I'm pairing them up, that's dividing it by 2. So there's 50 pairs of this sum of 101. So the sum, which I'm going to denote with a capital S, the sum is just 50, the number of pairs, times 101, which is the sum. And he got that the sum was 5,050 without individually adding each term. So now I ask, okay, how can we generalize this? So that's what I'll cover next. So now consider this series. And we're going to consider that, we're going to say that this is arithmetic. Okay? So we have u1 plus u2 plus u3 plus, all the way at the end, it would be u to the n, or u sub n minus 2 plus u sub n minus 1 plus u sub n. So remember that notation just means this is the term right before the last term, and this is the term before that one. So let's do our pairing again. So our pairs are going to be u1 plus u sub n. That's one pair. The next pair is going to be u sub 2 plus u sub n minus 1. So again, I'm just pairing like this. So then the third pair is going to be u sub 3 plus u sub n minus 2. Now, what do we know about those pairs? Well, we know that they're equivalent, that the sum of these pairs are all the same thing. If this is arithmetic, then it works out that all these pairs are going to equal the same sum. Think of what we just did. All right, so how many pairs are there? Well, we need to know how many terms there are. Well, the number of terms is just going to be whatever that n is on this u. So in this case, we have n terms, so the number of pairs is just going to be n divided by 2. All right, so the sum of those n terms, so that's the notation, S sub n, is going to be the number of pairs times, well, I can use any of these. Now, this is usually the easiest one to use because we can find the first term and the last term. We did that with sequences. So there's the formula for an arithmetic series. Now, in this formula, you would need to know the first term and you need to know the last term, and you also need to know the number of terms. Now, we know from sequences u sub n is equal to u sub 1 plus n minus 1 times your common difference d. Okay, so we can take this formula and substitute this. So let me do this in a different color. All right, so I can substitute this in for u sub n and get a second formula. All right, and that formula is going to be n divided by 2 times u sub 1 plus u sub 1 plus n minus 1 times d. Now we can do a little bit of combining like terms. These are like terms, so I get n over 2 times 2 u sub 1s plus n minus 1 times d. And this is our second formula. All right, so each of these formulas has their use, and we'll talk about where to use each of those. But I believe both of these are also on your formula chart. All right, but we see where they come from, and we've derived these. At the standard level, we don't need to know how to derive the geometric series formula, so I'm just going to give it to you. It's S sub n is equal to u1 times r to the n minus 1 divided by r minus 1. All right, and this only works if r is not equal to 1. Okay, your common ratio can't be 1. Technically, you can have a sequence that's geometric or a series that's geometric that has a common ratio of 1. But this formula discards that one because you'd have a division by 0 here. All right, so we're going to use that. All right, now we go to some examples. So it says for each infinite series below, decide whether it is arithmetic or geometric, then find the sum of the given term. So we want to take this series and find the sum of the first 9 terms. That's what this is saying. All right, so first we need to determine if it's arithmetic or geometric because that'll help us decide which of the 2 sets of formulas we're going to use. All right, so if we look here, it appears we're adding 4. That means it's arithmetic. All right, so we have a choice to make. We can either use the top formula or the bottom formula. Now notice, if we use the top formula, we need to find, n here would be 9 because we want to find the sum of the first 9 terms. Okay, well we'd have 9 divided by 2 times u sub 1 plus u9. We don't know what u9 is at this point. Okay, so we can either solve for u9 and then use this formula, or just use this formula because it doesn't involve that last term. All right, so I'm going to use this second one because I think it's easier. So S sub 9 is equal to 9 divided by 2 times 2 times the first term, which is 1, plus 9 minus 1 times 4. All right, now I just got to do some simplifying. So 9 halves times 2 plus, this is 8 times 4 is 32. So I have 9 halves times 34. And I'm just going to divide 34 by 2 to make that number a little smaller. And then I have to do 9 times 17, which 9 times 17, in my head, 63, is 153. And I just found the sum of this series to the 9th term. What would change if I just said find to u sub 30? The only thing that would change is what I plugged in for n. Everything else would remain the same. All right? So now let's go on to the second one. We have negative 2, minus 4, minus 8, minus, so we have minus, 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 which might make you think there's a negative common ratio. But remember, oh, by the way, this is geometric if you didn't see it already, okay? We're multiplying it looks by 2. We just need to figure out if it's positive 2 or negative 2. All right, so this is geometric. So we have to find the common ratio because it's used in this formula. So take a term, divide it by its previous, and we get positive 2. So actually positive 2 is the common ratio here. So the sum up until the 9th term is the first term, which is negative 2, times 2 to the 9th minus 1 divided by 2 minus 1. All right, so I'm gonna have to do that. That'll take, I could do it by hand, but that's a little obnoxious, 2 to the 9th. All right, and then I gotta multiply it by negative 2. So the answer I got was negative 1022. Another example. So we have the series 1/8 minus 1/4 plus 1/2 plus dot dot dot, and we need to find the sum up to the 12th term. All right, so again, decide if it's geometric or arithmetic. To me, this is geometric. I look at this and I see a geometric. It doesn't look like we're adding or subtracting anything. So now let's find the ratio. The common ratio is going to be negative 1/4 divided by 1/8, which is negative 1/4 times 8 over 1, which is negative 8 over 4, which is negative 2. Now just to make sure that this is geometric, if you're unsure, then take another ratio. It should be the same thing. So I should have 1/2 divided by 1/4, negative 1/4, is 1/2 times negative 4 over 1, which is negative 4 over 2, which is negative 2. So my ratio is matching up there. All right, so I'm going to erase this just to give myself the rest of the board. Our ratio is negative 2. I'm going to write that there so I don't forget it. All right, so the sum of the first 12 terms is u sub 1, which is 1/8, times your ratio to the n to the 12th minus 1 all over your common ratio, which is negative 2, minus 1. Again, these numbers are kind of big. I would say this is a calculator problem. So I'm going to go calculate that and come back with what I got. All right, so what I got after calculating, I got 1/8 times negative 1,365. Okay, and then Multiplying those two, my final answer is 1,365 divided by 8. If you need more examples like this, there's plenty more examples in the book. I'll leave it up to you whether you want to look at those or not. Okay, a new set of directions. It says for each finite series below, decide whether it's arithmetic or geometric, then find the sum. All right, so we have 5 plus 7 plus 9 plus all the way out to 39. So this appears to be an arithmetic series. So I need to decide what formula I want to use. So I accidentally erased them, but just to remind you, there's the two formulas. So which formula do we want to use? Well, we have the first term, we have the last term. However, the number of terms is unknown. So we need to solve for the number of terms if we want to use this one. Now, if we want to use this one, we need to know the number of terms to go here and here. We know the common difference, so either one you use, you need to find the number of terms in this series. So how do we do that? Well, we have from a previous section this formula, which we know u sub 1. We want to find n that corresponds to the term that's equal to 39. So I can say 39 is equal to 5 plus, we don't know n, so n minus 1 times the common difference, which is 2. All right, now solve this for n. So subtract 5, we'd have 34 is equal to n minus 1 times 2. Then divide by 2, so we'd have 17 is equal to n minus 1. So n is 18. And now we know the number of terms in this series. So I'm going to go ahead and use this first one. So I need to find the sum of the first 18 terms, or of the 18 terms, not the first. There's only 18 terms in this finite series. So we'd have 18 divided by 2 times 5 plus 39. So 18 divided by 2 is 9. 5 plus 39 is 44. And 9 times 44 is 396. So that's the sum of that finite series. All right, next one. We have a series written in sigma notation. So we first need to figure out, is this arithmetic or geometric? Well, if you remember the form of geometric sequences, that's in that form. So this is geometric. So again, the formula looks like this. So let's see what we have. Do we know u sub 1? We do not. Do we know the common ratio? We do if we know how to look at this equation, this form right here. This one right here. Okay, the common ratio is 3. Because in sequences, geometric sequences, we learned this formula. Okay, well that's in that form, it's just not n minus 1, it's just n, which that doesn't take away the fact that it's geometric, it's still geometric. Okay, they just define the terms a little bit differently. So r is 3, so we need to find u sub 1. Well, u sub 1 is going to be found by just plugging in 1 for n. So it would be negative 2 times 3 to the first power, which is just 6, negative 6. All right, so the sum, how many terms is there? Well, this upper limit tells you how many terms there are. There's 15 terms. So the sum of those 15 terms is going to be u sub 1, negative 6, times 3 to the 15th power minus 1, all divided by r, which is 3 minus 1. Which again, that's a big number. So I did that in the calculator, and I came out with negative 4,304,6718. Negative 43,046,718. All right, so that's how you find the sum of a finite arithmetic and geometric series. There are extra examples in the book. Check those out if you need them.